Welcome everyone to tonight's webinar. It is December 9th, and the topic is mapping our technosphere, discovering our biosphere. Our guest has resisted electronics since childhood and tried to reduce her consumption by 3% per month with questionable results. She spoke about the Internet's impacts on nature at the United Nations and on a panel with climatologist Dr. James Hansen. Her books include An Electronic Silent Spring, The Garden of Fertility, Honoring Our Cycles, and The Wholeness of a Broken Heart. She publishes at katiesinger.substack.com. Please welcome Katie Singer.
Thank you, Hart. And I'm just really grateful. Thank you to everyone for being here. I have I think this will go at most 20 minutes, my presentation. And then
How long?
I think 20
Okay.
minutes, between 15 and 20. So, um, and if Hart, if you can get the PowerPoint going, that would be great.
Sure.
Hmm. Okay, next slide, please. So our biosphere, our global ecosystem, evolves through cycles of heating and cooling and drying and moistening. Call these nature's ways, nature's laws. Flora and fauna are born, reproduce, die, and biodegrade. Our biosphere encompasses all land, waterways, and air, all plants, animals, insects, birds, microbes, and fungi. In the last few years, I've begun learning that healthy water cycles depend on soil that absorbs and retains water. To encourage healthy water cycles in soil, people can plant flowers, vegetables, and trees. Plants reduce water runoff and increase groundwater retention. Plants with differently sized leaves and different heights water each other as they transpire. Soil covered with leaves or hay or other mulch retains its moisture. Contours help dirt to absorb and hold water. With sufficient groundwater, we get healthy biosphere. Next. We also live in a technosphere. During the last 200 years or so, we've supercharged it. We eat food produced and preserved on faraway continents and transported to nearby grocery stores. We wash clothes, use medicines, heat and cool our homes, communicate, travel, teach children, and operate our military with industrially produced goods. Industrial production covers soil with power stations, factories, paved roads, parking lots, airports, and shopping malls that block soil's ability to absorb and hold water. Urban housing leaves few people with gardenable space. Recently, many people have become alarmed by the data centers creeping into neighborhoods. Data centers guzzle electricity and water and pollute water. They cause nearby residents' electricity and water bills to double or triple. Next. I want to respect our biosphere as much as possible. To do that, we need a fuller picture of the technosphere. Next. I count 4 pillars in the human-made technosphere. There's electricity, and that is made up of substations, transformers, cables, utility meters, and fuel for the grid. Number 2 is manufacturing, which includes designing, mining, smelting, refining, chemicals, shipping, assembly plants, and packaging. Number 3 is infrastructure, roads and trucks, airports and planes, railroads and trains, shipping lanes and ships, cement, waste dumps, access networks, data centers. And the fourth pillar is our rules and regulations, acts of Congress, as well as municipal ordinances and laws. Next. First off, the technosphere needs power. Every fuel source has ecological consequences. Most electricity is now powered by natural gas, a fossil fuel. Coal, nuclear power, hydropower, solar, photovoltaics, wind turbines, geothermal power, and batteries each require water during their manufacture, and they generate waste. Facebook, Google, and Amazon routinely cut down forests to build solar facilities and data centers. They call the data centers powered by green renewable energy, but solar and wind provide only intermittent power, and neither solar panels nor wind turbines biodegrade. There's much more to say about this, but I am focused today on telecommunications. Next. My understanding of manufacturing, the technosphere's second pillar, started with transistors, every computer's backbone. Transistors, also called semiconductors, are made from silicon. Silicon is an element, but you can't find it in pure form in nature. And of course, solar panel wafers are also made from silicon. Manufacturers gather pure quartz gravel, petroleum coke, that's an oil byproduct, and dense moist wood, sometimes from the Amazon, and then transport these three things internationally, next slide, to a smelter that's kept at 3,000 degrees Fahrenheit, that's 1650 Celsius, for 6 or 7 years at a time. One smelter needs at least 2 power sources, like 2 coal-fired power plants or 1 each of coal, nuclear, and hydropower. You need multiple sources of fuel because interrupting delivery of power, electric power, to a smelter can blow it up. After the smelter reduces the silicon from the quartz, we still need another handful of energy-intensive toxic waste-emitting processes before we get silicon pure enough for transistors or solar panel wafers. About 15 years ago, manufacturers made 1,000 times more transistors than farmers grew grains of wheat and rice combined. I don't know what that number is today, but it's got to be much larger. Next slide, please. To make transistors electrically conductive, they're doped with hundreds of chemicals. After each chemical's application, chips are rinsed with ultra-pure water. You know how filtered drinking water has had sodium, chloride, chromium, and lead removed? Ultra-pure water goes through much more intensive filtering. One factory guzzles millions of gallons of ultra-pure water every day. Some factories, clean the used water. Many do not. Transistors' water demands are often prioritized over people's needs and farmers' needs. In the United States, we're building 3 transistor fabs in Arizona, which is not known for its water. A Japanese corporation, SoftBank, now proposes building chip fabs, packaging plants, processing facilities, and housing for all of the workers in Trump industrial parks on federal lands. The idea is to create a semiconductor supply chain that competes with China. Next slide. To conduct electricity, computers use copper. Chile has the world's largest copper mine. Every kilogram of mined copper generates at least 210 kilograms of waste. Next slide. Computers also use gold to conduct electricity. This miner is mixing crushed gold ore with mercury. The mercury binds to gold dust. When the miner cooks the lump in a frying pan, probably the same frying pan used to make dinner, the mercury vaporizes and leaves a sellable gold nugget. As the mercury vapor travels, it mixes with rain and snowfall and contaminates water and soil and aquatic systems. Acid rain. Small-scale gold mining is the world's largest source of mercury pollution. Next slide. For electric charge, mobile devices require batteries that likely contain cobalt. This is Monica, a 4-year-old cobalt miner in the Democratic Republic of Congo. Children have been buried alive mining for cobalt. Next slide. Exposure to dust generated by mining causes birth defects and harms wildlife. Since year 2000, Grauer's gorilla has lost 77% of its population, partly from mining coltan for cell phone batteries. Next slide. Batteries also contain lithium. Lithium processors might use brine evaporation, like this Chilean mine, which consumes 65% of the area's water. Filtering 1 ton of lithium uses about 500,000 gallons of water. Chemicals used to refine lithium, like hydrochloric acid, can leak into waterways, pollute local wells and soil, and impact fish as far as 150 miles downstream. Discarding lithium-ion batteries also can contaminate groundwater. Next slide. These Tibetans are protesting lithium processing near their river. It kills their fish. Next slide. Lithium is also extracted by hard rock mining, which involves chemicals, or direct lithium extraction. In 2023, Lithium Americas Corporation began mining thousands of acres at Thacker Pass, Nevada, for lithium for EV batteries. Mining lithium at Thacker Pass uses and pollutes 5 million gallons of water every day. Next slide. Batteries use nickel to store power. Circuit breakers use nickel to prevent corrosion. These are nickel tailings in Ontario, Canada. This is toxic waste generated during manufacturing. If we look at a computer from its cradle to its grave, 81% of its lifetime energy use will be consumed, and the vast majority of its toxic waste will be generated before the laptop's end user turns it on for the first time. It's therefore much better to keep computers and appliances and vehicles in good repair than to buy anything new. If you must replace something, go for a used device. Next slide, please. During manufacturing, raw materials travel from one station to the next on ships that use highly polluting bunker fuel. Next slide. In Chinese factories, young people earn about 457 US per month to sterilize circuit boards with solvents like N-hexane. Chronic exposure to N-hexane can cause peripheral nervous system failure, leukemia, and muscular weakness. Next slide. This is my list of about 125 substances that go into making one smartphone, or any mobile device, or any computerized appliance or vehicle. Next slide. Next slide, please. Burning e-waste. At the end of their usable lives, electronics get shipped again, this time to Africa or India. Every year, each North American generates about 47 pounds of hazardous electronic waste. Globally, we humans generate about 68 million tons of end-of-life electronic waste. And again, these figures do not include the waste generated during extraction, smelting, refining, assembly, or transport of computers' raw materials. To find sellable copper scraps and fund his education, this young man burns dead computers and inhales their toxic fumes. Josh Lepofsky, he's written wonderful books about e-waste. He reports that cleaning up manufacturing's e-waste leads to its own discards. For every pound of contaminant extracted for remediation from Silicon Valley's former electronics manufacturing zones, about 4,000 pounds of CO2 are released into the atmosphere from those treatment processes. Some debris will last for centuries. Next slide, please. Of course, accessing the internet requires much more than a manufactured computer. Next slide. Going online requires an access network. An access network is made up of satellites, transmitters, routers, cables, cell sites, and batteries, all things needing to be manufactured, and requires enormous energy to operate. And I should say that mobile access takes much more energy than wired access. These pictures show a 4G cell tower on the left and a 5G cell site on the right, the fourth and fifth generations of mobile access networks. Some people predict that we will soon have cell sites every 750 feet. Next slide. Websites, videos, video games, online stores, bank records, medical records, social media, and PowerPoints like this one need data storage centers. 40% of data centers' electricity goes to cooling systems, which demand water. Daily, a typical data center consumes about 5 million gallons of water, the same amount consumed by a city of 50,000 people. To prevent bacterial growth, data centers often treat their water with chemicals, which effectively removes it from the local water cycle. About 2/3 of new data centers built or in development since 2022 are in places already in significant water stress. And I've read that I think in the last, like 10 years ago, we might have had 400 data centers in the country, and now we've got about 5,000. In 2012, Greenpeace found that if data storage centers were a country, they would rank 5th in use of energy worldwide. By the end of this decade, we can expect data centers' global electricity demand to double, and most of this demand will be met by fossil fuels. And of course, every server that you see in the top image there requires manufacturing. Servers are replaced about every 3 years. Next slide, please. So the fourth pillar, rules and regulations. In 1886, the Supreme Court ruled that corporations are persons who hold the same protections as natural persons. And since then, natural people have been significantly unable to, or hampered, to regulate corporate behavior. Newer laws support this endeavor. The Endangered Species Act of 1973 makes it unlawful to harm, kill, capture, or collect any endangered species of fish or wildlife. However, if an applicant wanting to drill oil or mine lithium or deploy wind turbines, for example, submits a plan and the Fish and Wildlife Service or the National Marine Fisheries Service finds that the project's harm to endangered species will be incidental, then the agency will issue a permit for the corporation's project. There's the Telecommunications Act of 1996, and I'll say this is really what got me, when I learned this Section 704, that inspired decades of my research and writing about all of this stuff. Section 704 of the Telecom Act states that no municipality can deny a permit to install cellular antennas based on the environmental or health effects of exposure to their electromagnetic radiation emissions. Several states have banned the rights of nature. For example, when people in Ohio tried to ban Walmart from using plastic bags, the Ohio legislature pushed back and said, prohibited that act and prohibited the rights of nature. The Trump EPA and the Army Corps of Engineers have proposed the polluted water rule. If enacted, it would let polluters dump in and destroy more waters across the country than at any time in the last 50 years. The FCC now has bills proposed that would fast-track cell tower permits and end the remaining local authority over cell site placement. The Trump administration and big tech have also proposed a rule called Eliminating State Law Obstruction of National AI Policy. If enacted, this law would penalize U.S. states that pass or have already passed laws that limit AI in any way. They would threaten litigation against the state and withhold federal funds for broadband. In short, a power grid and telecommunications that respect nature do not exist. Laws that respect health, public health, and safety are being whittled away. Next slide, please. This is a map of critical minerals in the United States. And one of the things I've thought of is if many of you maybe have heard of the bioregional practice of tracing your water supply from precipitation to tap. And other people have also proposed tracing the minerals within your bioregion and, you know, what minerals are used, what are their tailings, what mines are no longer in use, but, you know, still available. Next slide. I want to go back to the biosphere. I actually want to go to my bioregion, my watershed. The United States has 6 main watersheds and about 2,100 smaller ones. If I aim to live within my bioregion's offerings of food, water, fuel, and ores, I don't see how I can still have telecommunications or maybe any industrially produced goods. If I don't have web access, I can't participate in modern society and attend online webinars like this one. Still, I wonder, how can we live more bioregionally? How can we reduce our technosphere's consumption of water and impacts to water? I'm encouraged by schools and even countries. As of tomorrow, December 10th, Australia will prohibit children from using social media. And we have lots of schools now that are prohibiting children from having smartphones. Some people have proposed prohibiting children from using any electronic device, at least until reading, writing, and math are mastered on paper. And if we do that, then that slows down the supply chain, because once anyone starts using an electronic device, then they start buying them and entering that supply chain. I love the idea of challenging every smartphone user to trace the supply chain of one substance in their phone and to share their research. I love staging energy reduction contests or water reduction contests between communities and challenging engineers to design biodegradable computers or computers made only with materials from within their bioregion. And of course, all of this requires restoring our orientation toward seasonal changes, toward nature, rather than toward digital changes. Next slide. So that's my presentation, and I also have resources that I will try and put in the chat. But I'm really eager to hear from you and what your ideas are for reducing our impacts. Yeah, and also just your response to what I've presented here.